All right, so we are on number 80. If you get there to it in your packet. Okay. If you remember this formula, you are going to want to write down that formula that we have a to the inside over the outside is going to be equal to, we have the root, or the bottom, let's say the bottom root of a to the top. Okay, so this one we've got 5 to the top is on the inside, and that's a 1. And on the outside, we know that that is just a 2 because it's the square root. So we're just going to leave this as 5 to the 1/2 power. Okay, same thing with this one. We've got 6, and that's to the first power over 3. Okay, 6 to the 1/3. All right, same thing here. We've got x to the 3/4, top over the bottom. All right, 27. There's nothing on it, so that's 27 to the first, so 27 to the third, and c to the 2/3. If in your calculator you take 27 to the 1/3 power, you're going to get 3, and then we have 3c to the 2/3. Okay, this one's in parentheses, so we've got 2g to the 4 over, remember if there's nothing out here it's a 2, which gives us 2g squared. Now we have to distribute. 2 squared g squared equals 4g squared. Okay, not so bad. Here we've got 36 to the 1/2, b to the 1/2. If you take 36 to the 1/2, you get 6, and then we still have d to the 1/2. Make sure you simplify that. Okay, here we have 8 to the 1/3, b to the 5/3. 8 to the 1/3 is 2, so 2b to the 5/3. This one we didn't go over in class, so we will talk about this. If this is on the bottom, it just makes your fraction negative. So we've got 8, and then we have x to the 15 over 7, and since it's in the bottom of the fraction, it's going to be negative 15/7. So if you didn't get that one, that's okay. Okay, if you got something close to this, that would be pretty awesome at this point, because we didn't talk about negative exponents when we were talking about the fraction ones. Okay, so now we've got to do it the other way. What was it? We have, so 3 doesn't have an exponent on it, so that stays there. And then the root here is f to the top, which is 3, and bottom goes on the outside. Okay, here 5 stays. We have the 6th root of g, and then it's just a square root of h, and it just stays just like this. There's nothing else to simplify. Okay, now we've got parentheses. We've got 64 to the top, and then the 4th root. Okay, and you can just leave that, sorry, it's 64b, not just 64. Okay, here we've got 25x, and it's just the square root of 25x. If you wanted to simplify this, what's the square root of 25? It's 5, so we could take out the 5, and then it would still be times the root of x. Okay, all right, now these are the fun ones. We have here these fun word problems. All right, so it says a catapult launches a boulder with an upward velocity of 112 feet per second. The height of the boulder is feet and t is seconds, and we have this equation, and that's the big one. Okay, how long does it take the boulder to reach its maximum height? Okay, and if we're going maximum height, that's when we're going to have this parabola guy, and we want that max height. So if we go back to our calculator, Okay, and we go to our y equals. We have negative 16x squared. What's the rest here? Plus 112x plus 30. Okay, and when we graph this guy, okay, we see all kinds of funky stuff. So let's go zoom fit, so zoom 0. Okay, still looks kind of funny, so I actually am going to see if this lets me trace it all the way up here, if it changes my screen, and it doesn't, of course not. Okay, so what I'm going to do actually, I'm going to change my window. Okay, my x minimum I know is going to be 0. My x max I'm going to leave at 10. My y minimum I like to be 0. My y max, if I look at my graph, 112 is in this thing, so I'm going to go above 112. Maybe go 125. And now let's look at the graph. Not high enough, did I? Okay, so let's go window again, and I'm not high enough. So let's go my y max, maybe try 250 and graph it. Yes. Now I'm on there. Okay, so now we want to find that maximum height. So I'm going to go second, calculate, and I want to find my max, so that's 4. Left bound, we got to get to the left side. And we hit enter. Right bound. I'm going to get over to the right side, hit enter. And our guess is going to be in the middle. Alright, so it gave us about 3.5 and 226. So if we go back here, I have 3.5 and 226. So our x was 3.5, our y was 226. Okay, so our max height is going to be 226 feet. Okay, and at what point was it there? Well, remember our x is our seconds, so it got to its highest point at 3.5 seconds. Okay. Alright, you purchased a used car for $5,000. So remember we have $5,000. Okay, depreciates. So that means we are going down in value. So if you remember, this is 1.15, and to get what's inside there, we have to take 1 minus 0.15. So we are going to end up with 0.85, and then to the years is going to be for 5 years. Okay, so in your calculator you got to take 0.85 to the 5th power. So if I get out of here and I go 0.85, and then remember this is your to the 5th power, and hit enter. Okay, make sure you hit enter, and then you can times by your $5,000 and hit enter. Okay, and this is going to be the value of your car. Make sure you write it down correctly because we're talking about money. So about $2,218.53 is what your car is going to be worth after 5 years. Okay, we've got 5 Spanish words. Okay, if I memorize 2 times that amount, okay, I'm going to go 2, and then each week for the next 10 weeks, so 10 weeks. Okay, so we're going to go 2 to the 10th power. Make sure you hit enter, and then multiply it by 5, and we've got 5,120 words that we just memorized by just starting with 5 of them. Okay, so now if we go here, now I've got 5 Spanish words again, 2 times that amount. Now we're going to double that every 2 weeks for 10 weeks. So if I'm going every 2 weeks for 10 weeks, that really only gives me memorization for 5 different times. So now you're going 2 to the 5th power, hit enter, multiply it by 5, and now we've only memorized 160 words. So way more beneficial for you to memorize it every week rather than every 2 weeks. All right, so now we have a certain number of, or the number of trees in a certain rainforest are dying at a rate of 5% each year. So that's 0.05, and if they're dying, they're going down. So we're going 1 minus 0.05. So we're starting with 650,000 trees. We end up with 0.95 in our parentheses because it's depreciating in 45 years. That's where we want our time. So you're going 0.95 to the 45th power, and then you can multiply that. Make sure you hit enter, times 650,000, and you should get approximately 64,636 trees left in that forest. Okay, we've got the area of the playground. Okay, it's going to be a rectangle, and it's 50 square yards. Okay, it says the length is 2 times the width. So if the width is x, the length would be 2x, because 2 times the width. Okay, and then the area is going to be 50. So we've got to take 2x times x to find area is going to be 50. So 2x squared equals 50. X squared equals 25, and then we take the square root of both sides, and we get x equals 5. If x equals 5, that's the width. So the width would be 5 yards, and the length then is 2 times that, so that is going to be 10 yards. All right, another ball thrown one. We've got negative 16t squared plus 45t plus 6. So we punch this in, negative 16x squared plus, what is it, 45? Yep, 45t plus 65. And then we want to get rid of that 0 there on the end. Alright, so now if we graph this guy, we can see it. Okay, we could bring it down if we want, but we can see it. And it is asking again for its maximum height and how long it's going to take. So second, calculate. We want to find the maximum. Okay, so left bound, we've got to get over there. Left bound, enter. Right bound, gotta come around. Enter. And then let's get to the top of this guy and hit enter. And so we've got about 1.4, comma, what is that, 97.6? So 1.4, comma, 97.6, is that what that says? Oh, I typed it in wrong. Shoot! Alright, so let's go over here. It's only supposed to be plus 6 instead of plus 65. Sorry, guys. So get rid of that. Alright, now I can hit graph. I'm going to bring my window down a little bit. Probably to maybe 50. Hit graph. Now I can see this guy. Alright, so second, calculate. Maximum is 4. Left bound. Enter. Right bound, enter. Get to the top of that guy. Alright, so now 1.4 and 37.6. So that makes a little bit more sense, 37.6. Okay, so maximum height, remember this is x, this is y, so my height that it got up to 37.6 feet, and the time that it took is over here. It took 1.4 seconds for it to get to its maximum height. Okay, now it's a little different. Now it's when will it hit the ground. So see if we can type this in the right way this time. Negative 16. So negative 16 t squared, and then plus 100. So I hit graph. Okay, can't see the top, but since I don't need the top, I'm going to be okay, because what I'm looking for is when it hits the ground. And when it hits the ground is this guy right here. Okay, so we want this to be where, who is this guy? Y is, or where x is 0. Okay, so if we look at this, if this is 2 and this is 3, it's going to be right in between there. Maybe about we can say about 2.5 seconds is when that guy hits the ground. Okay, and last problem. Okay, now we're going, a rocket is launched from atop a 65-foot cliff. Okay, and now again, when is it going to hit the ground? So we're looking for that 0 spot. Okay, so I'm going into my y equals, and I've got my negative 16 x squared plus 113x and plus 65 this time. Okay, so if I hit graph, okay, so now I've got this. I don't have to see the top because I'm looking for when it hits the ground. So I could basically just count this over. 1, 2, 3, 4, 5, 6, 7, a little bit between 7 and 8, or about, I could say about 7.6 seconds or 7.5 seconds. Okay, you just need to know that it's between 7 and 8. Alright, so that is your entire review packet. If you have any questions, I will be here early on both Tuesday, Wednesday, and Thursday, so come and find me and we can work those out. Good luck!